1, action. All right, so the first thing I would do is go to File, Document Options, and we're going to do 3 different sketches. The first sketch was what? The in-center. It's okay. Don't be afraid of the internet. The in-center, and then the circumcenter, and then the, what was the last one?
Centroid.
Great. And so what you'll see here is, Grace, at the bottom, you have the 3 different points of concurrency. So to create an in-center, you're first going to start with the triangle. And the in-center is created by what? How do you make an in-center?
The bisector.
The angle bisectors. So if I bisect that angle, construct angle bisector. And again, if there's a trick to it, you want to make sure that the vertex of the triangle is the second point. So 1, 2, 3, construct angle bisector. You actually only need 2 of the 3 to get that point of concurrency, and that will allow you to construct the triangle, or excuse me, construct the circle. The only other thing that you need is remember that you're measuring the shortest distance from the point to the side, so you're also going to have to construct a perpendicular line. Okay, and what that does is it gives you the pathway. Let me mark this. It gives you the pathway to draw your radius. So now when you use your circle, the center of the circle is at the point of concurrency. You go all the way out to that point of intersection there, and you now have constructed the circle inside the triangle. So no matter how I move this around, it's always going to stay in there. Any questions? All right, next one, circumcenter. How do you construct a circumcenter? This is the what?
Bisector.
Perpendicular bisector of the sides of the triangle. So you first have to start by constructing a midpoint, and after you have the midpoint, you tell it to construct a perpendicular line perpendicular to the side through this point. All right, so we have one perpendicular line. We'll do it on another one here. So construct midpoint, and then a perpendicular line through this point perpendicular to the side. And we now have our point of concurrency. The circle goes from this point of concurrency to one of the vertices, and you can see the circle now goes through all 3 vertices of the triangle. Okay, so no matter how I move it, it's good to go. Johnny?
When should we fix our things by?
Monday? Can you email to me by Monday? That work? All right, last one, centroid. Where's the centroid come from? The medians, right? So I just need the midpoint, so construct midpoints. And then all you're going to do is connect the vertex to the midpoint of the opposite side. Vertex, midpoint, vertex, midpoint. And we now have our point of concurrency. And that's that. What's fancy about the centroid? Does anyone not remember? The distance from the vertex to the centroid?
Is always two-thirds of the centroid to the midpoint.
Centroid to the midpoint. So now if I measure that one, right? So we're going to go number calculate. Vertex to centroid divided by centroid to midpoint will always be a ratio of 2 to 1. So no matter how I move this or the distances change, it always maintains that ratio. Cool?